In this presentation, we're going to look at the Anova test for means. Now, the Anova test for means is used to compare the means of multiple samples or multiple categories, or in more commonly used sense, the multiple treatment groups. If you're familiar with experimental design, that is makes sense. So the version we're going to use is SPSS version 19. The dataset is Iris Anova with the little hyphen there, and the variable we're going to look at in particular is called petal length. Now, first we must specify the null and alternative hypothesis. Now we have three groups for this particular data set, so that's why that 3 is in brackets. But for other data sets, it might be a bit different. The mean value, as in the mean value of petal length, is the same for all three groups. The alternative hypothesis is that one of the groups has a different mean value of petal length to the others. So we have let's look at the data set here now. Let's bring that up. So we're going to look at this variable here, petal length, and we have three groups, setosa, versicolor, and virginica. But we actually have to code them using numeric values here. So that's why I have a second variable over here, species number. So species number 1 corresponds to setosa, species number 2 corresponds to versicolor, and species number 3 corresponds to virginica. The command won't recognize species because it is text, where it will recognize a number that corresponds to a group number. So that is the reason for that. So we go to analyze, and then we go to compare means, and then we go down here to one-way ANOVA. So I'm going to click on that. Now it's all set up for us there. I'm going to undo that again so we can just bring it in. See how I select it. I am going to select petal length only, so there. I put that in there, and I'm going to select species number. Because again, you might notice that species itself is not available to us. Let's look at some of the options we have. Polynomial, yeah, I'm not going to look at that. I'm not going to consider that in this presentation. There are a couple of post-hoc tests. I'm going to click on the Tukey test, but there's a wide variety of additional inference procedures that we can use. I will deal with them another time. There's also options there. Put in descriptive statistics, homogeneity of variance test, and the means plot. I will leave them in, but I'm not going to concentrate on them as much in the discussion. So continue, and okay. Here is the output on the way. So there we have there's some descriptive statistics. We have the mean of three groups. The number of samples valid observations for three groups. This is group 1, group 2, group 3, setosa, versicolor, virginica. We have 50 observations of each. Those are the mean values, standard deviation, and so on. There is also quite a bit of descriptive statistics information for each of the three categories. I'm going to move on from that. What we have here is also the Levine test for homogeneity of variances. In this example, we reject the notion that they have equal variances. So that's an interesting matter. I'm not going to look at that though now, but that's something to look at when you get better at this. The test for homogeneity of variances, that this is an important little statistic here. I'm going to look at the Anova procedure there. Let's quickly just discuss the Anova procedure. And this is, in particular, the procedure we are going to look at. I'm just going to scroll down here first. This is the post-hoc tests and the Tukey summary. I'll try and scroll out of that. This here is the means plot. This is the mean of group 1, it's 1.5. This is the mean of group 2, it's roughly 4.5. This is the mean of group 3, it's roughly 5.5. Let's go back up. This is the key thing we're looking at, the Anova procedure. So this is the key p-value here. So what we're interested in is this significance value here is how we determine whether or not to reject or fail to reject the null hypothesis. In this case, we have a very small p-value, a very small significance value. The p-value is called significance in SPSS, and therefore, in this case, we reject the null hypothesis. They do not all have equal means. One group has a significantly different mean to the rest. Let's just go back up here a second and see, or down here a second. It is actually very obviously group 1 has a much different mean from the rest of the values there. And in that case, that is very compelling evidence in favor of rejecting the null hypothesis. So that ends our presentation. Bye.